Our last lesson of Unit 11 is today, and it deals with areas and volumes of similar solids. So that's kind of the big thing we're talking about, similar solids. And those are solids that have the same shape and their corresponding dimensions. So like their heights, their radii, whatever, they are proportional. Okay, so maybe they're like both cylinders, but the dimensions of the bigger cylinder is double the dimensions of the smaller cylinder. That's kind of what that means. Now, proportional, that means that they have the same similarity ratio. So if you compare their two heights, they're in the same ratio as the two radii would be. Now, you guys did a lesson that was very similar to this, no pun intended, similar, first semester. The difference is this lesson deals with three-dimensional similar figures, and last semester it just dealt with two-dimensional similar figures. Okay, so since we're kind of talking about three-dimensional, we can go the volume route, which is kind of what makes this a little bit different. We never did volume first semester. So we're going to kind of discover the big idea, which is at the bottom here. We're going to discover the big idea by looking at these two similar cylinders. So they're similar, that just means they have the same shape, they're both cylinders, and their dimensions are proportional. So the first thing we want to do is find the similarity ratio from the small cylinder to the large cylinder. Basically, you just take two dimensions that go together, maybe the two radii, the two heights, and you make a fraction or a ratio out of them. So if I do like 5/6, I can't reduce that, that's the similarity ratio. If you would have done the heights, 10/12, realize you could have divided both of those by 2, and you would have gotten 5/6 again. Okay, so if you just relate two corresponding dimensions and reduce it, that's the similarity ratio. I'll call that SR today. Similarity ratio, how the two shapes relate to one another. Okay, so we're going to find the surface area of both figures, the volume of both figures, and then we're going to analyze those numbers. All right, we've done all of this before, so I'm going to go through this part pretty quickly. Surface area of a cylinder is 2 pi RH plus 2 pi R squared. So let's do the small cylinder first. So that'd be 2 pi 5 times 10 plus 2 pi 5 squared. We're going to leave it in terms of pi, so this first group would be 100 pi plus 2 times 5 squared would be 50 pi. So the surface area of the small cylinder is 150 pi. For the large cylinder, let's see, it'd be 2 pi, the radius is 6, and the height is 12, plus 2 pi 6 squared. So this would be 144 pi plus 72 pi. And if I added those together, that'd be 216 pi. They want me to write a ratio comparing the small surface area to the larger surface area. So I'm just going to make a fraction out of those two numbers and reduce it, always reduce. The pi's would cancel, and I want to simplify 150 over 216. If you have a calculator like mine, if you just type it in as a fraction, it'll automatically reduce it for you, which is so convenient. The area ratio of these two things related is 25/36. Okay, let's do the same thing with the volume, and again I'm going to go through this pretty quickly because we've done this before. Volume formula is pi r squared h. So let's see, for the small cylinder, pi 5 squared times 10. So in terms of pi, that would be 250 pi. For the larger cylinder, that'd be pi 6 squared times h. 432 pi. And if I made a ratio, 250 pi over 432 pi, and reduced it again, pi's would cancel out. If I did the little trick in my calculator, I just typed it in as a fraction, it'll reduce it for me, and it'd be 125 over 216. All right, we just discovered all of this. Kind of a lot of work, but there's a big idea going on here. Okay, here's the similarity ratio, 5 over 6. It's kind of how the dimensions relate to one another. When I did the area, the ratio that I got was 25 over 36. When I did the volume, I got 125 over 216. These three fractions, you guys, are related. And if you can't tell, if you take the similarity ratio and you square both of those numbers, 5 squared is 25, 6 squared is 36, that gets you the area ratio, how the two areas are related. If I would have gone back and cubed the two numbers in my similarity ratio, 5 to the third is 125, and 6 to the third is 216. So if you cube the similarity ratio, that's how the volumes are related. Okay, so let's kind of generalize that and get it into this big idea down here. This is the thing you need to know for today. There's three ratios that relate areas, volumes, and dimensions of similar solids. So the first one's called the similarity ratio, and I'm going to say SR. For area ratio, I'm going to say AR, and volume ratio, I'm going to say VR. Okay, so similarity ratio is just what you get when you make a fraction out of dimensions that go together. So we're going to call that A over B. 5 over 6, 2 over 3, whatever you get when you put dimensions into a fraction. You can use that to get the area ratio. If you just square your two numbers, that's what you get, so I'm going to call that A squared over B squared. And if you cube the similarity ratio, that gets you how the volumes are related. So I'm going to call that A cubed over B cubed. This is what you need to know. Now, there's a pretty easy way to remember this, at least this is how I remember it. I think to myself how I would write an area. And I know that I would say like, oh, centimeters squared, inches squared, etc. So since I write that squared, I know the area ratio is when A and B have a squared on them. If you think about how you write volume, you write inches cubed, volume cubed, etc. So the volume ratio has the cubed on them. Okay, so I'm going to recopy this onto the back because those are the three things that I need to know. You're going to use these three ratios on all of these problems here. Okay, so there's my reminder. Area squared, volumes cubed. Now, my suggestion is that you write all three of these ratios on every single problem, regardless of what you're trying to find. So example 1 says, find the similarity ratio of two cubes. So I'm trying to find SR of two cubes that have volumes of 729 and 1,331. Every single problem, I make my list. And then I kind of figure out what I've got and what I can make a ratio out of. Now, I want the similarity ratio right here, but I have to work with what they give me. And notice they gave me volumes, 729 and 1,331. Whatever they give you, you want to make a fraction or a ratio out of that. So I'm going to make a fraction out of these two numbers, and that's going to be the volume ratio, because these are volumes. Don't make the mistake of putting this as the similarity ratio. If they're volumes, it's a volume ratio. Okay, so I'm all the way down here at A cubed over B cubed, and I want A over B. So I need to get the similarity ratio. So you've got to think, how do you get rid of the cubed? We've been doing that with spheres. To get rid of the cubed, you do cubed root. And I'm going to do that to both of these numbers here. So remember to get that on my calculator. I do 3 second caret to get that little symbol there, 729. Okay, so that's going to give me the top number of the similarity ratio is 9. And then I have to cubed root, wrong one, 1,331. And that would give me 11. Okay, well that's exactly what they wanted me to find, so I don't even really need to find the area ratio. This is my answer. 9 over 11 would be how the dimensions are related, similarity ratio. Okay, example 2. So same thing, before I even read it, I'm going to write my 3 ratios because I know I need to use those. And realize, you guys, your hint that you're going to use these problems, because these will be just like thrown into the exam kind of anywhere and everywhere. Your hint that you do these 3 ratios is if you see the word similar. So if they're talking about similar solids, you need to do these 3 ratios. Okay, look for that on the exam. Example 2 says the lateral areas. Okay, I'm probably thinking area ratio of 2 similar paint cans are 16 and 25. Okay, they give me 2 areas. I can write the area ratio. 16 over 25. Then they say, all right, well, the volume of the small can is 1,157. We want to find the volume of the large can. So if we want to find a missing volume, we need the volume ratio. But I don't have the volume ratio. These were lateral areas. I have the area ratio. Now I'm in the middle. I'm at a squared over b squared. You always have to jump up to the top and get the similarity ratio before you can jump down and get the volume ratio. So if I'm at a squared and I just want plain a, I'm going to square root both of those numbers to get me the similarity ratio. So square root of 16 is 4, square root of 25 is 5. Now I can jump down here and get the volume ratio. Okay, to go from similarity to volume, you cube both of your numbers. So if I do 4 cubed and 5 cubed, that's going to get me the volume ratio. Remember, you can use the caret button, just like that, to cube something. Okay, so here's the volume ratio. That's not your answer. You want to use the volume ratio to find a missing volume. Okay, so we need to set up a proportion. All right, if we want to find a missing volume, a missing surface area, a missing height, if you want to find something that's missing, you need to set up a proportion. Something like this. Use the volume ratio because that is what we're trying to find, a volume. Okay, so I'm going to take 64 over 125. This is how the volumes are related. Now be consistent. I did like the small number over the big number. So over here, I need to do the small over the big as well. And they told me the volume of the small can is 1,157. So put that on top. We don't know the volume of the large can, so put X on bottom. Once you've set up your proportion, you just cross multiply and divide. So I'm just going to put that in my calculator all at once. 125 times 1,157 divided by 64. And I get, they didn't tell me how to round, let's just say 2,259.8 would be the volume of the large can, centimeters cubed. Whew, kind of a lot of steps. Let's do one more. All right, I see the word similar. I know that I need to write my 3 ratios. I'm going to use them to find a missing surface area. But notice they say the volumes of 2 similar solids are 128 and 250. They give me the volumes. I can use that to write the volume ratio. And I always do small number over big number. The surface area of the larger solid is 250. I want to find the surface area of the small solid. If you want to find a missing surface area, you need the area ratio. You're going to use that in your proportion, but I've got to fill in these other ratios before I can do that. Okay, so we're at the bottom at a cubed over b cubed. You always got to jump back up to the top to get the similarity first. Okay, watch what's about to happen. I'm going to try to do the cubed root of 128, but it is a really gross decimal. If that happens to you, they're not going to give you problems that don't work out nicely. If that happens, that means you can reduce this. So use that trick I showed you on the front of the notes. Just type your ratio in as a fraction, and it's going to reduce it for you. 64 over 125. Now if I cubed root both of these numbers, it's going to work out nicely. Okay, so the cubed root of 64 is 4, and the cubed root of 125 is 5. That is much nicer to work with than the 5 point whatever that I got the first time. Okay, we're at the top, a over b. We need to square those two numbers to get the area ratio. So 4 squared over 5 squared, 16 over 25. All right, if you need to find a missing surface area, you need to set up a proportion. And I'm going to use the ratio that makes sense. If I'm finding a missing area, I need to use the area ratio, 16 over 25. Be consistent, I did small over big. They told me that the surface area of the larger solid is 250. So put that on bottom. We don't know the surface area of the small one. And then I just cross multiply and divide. And I get the surface area is 160 meters squared.